Hi students, welcome to Max Point of View. Today we are going to solve each and every theory question from the chapter Refraction of Light, that too part C, simple application of refraction of light. That is nothing but apparent depth, real depth and shift. So before solving these questions, we need to understand the concept. That's why my suggestion is watch the concept video first, and after solving all the theory questions we are going to solve all the remaining numericals. The concept video and the numerical videos both will be available in the description box. So without wasting any time, we'll start with our first question. Our first question, how is the refractive index of a medium related to real and apparent depth of the object in the medium? See, when it comes to how it is related, what is the relation, all those things, many students will get confused what to write in the exam. Very simple, listen. In this case, they are talking about refractive index, real depth and apparent depth. How many physical quantities are there? 1, 2, 3. Okay, if they are asking any question related to more than two physical quantities, then write the formula. Okay, then write the formula. See, refractive index, real depth, apparent depth, all the three are three different physical quantities. What do you mean by physical quantities? Anything which you can measure. Okay, it's a physical quantity. We can measure refractive index, we can measure real depth, apparent depth. I know many students will not understand what is real and apparent depth. That means you have not seen the concept video. So my suggestion is watch the concept video, then come to this video, then you will understand everything. So here three physical quantities. If they are asking a relation between three physical quantities, then go for the formula. If they are asking how refractive index is related to only real depth, or how refractive index is related to only apparent depth, then instead of going for formula, you have to write whether they are directly proportional or inversely proportional. Whether they are directly proportional or inversely proportional, that depends upon the formula. So or else you can write the formula itself. Here for this question also you can write the formula, but my suggestion is always go for whether they are directly proportional or inversely proportional, because when you write whether they are directly proportional or inversely proportional, who are correcting your paper, they will get to know you have a complete knowledge. Okay, so don't write the formula whenever they are asking only two physical quantities. How refractive index is related to real depth, or how refractive index is related to apparent depth. Not only in this concept, in throughout physics, if they are asking any relation between any two physical quantities, whether just write whether directly proportional or inversely proportional. That's it. Now we'll go for this question. In this question, it is clearly mentioned that three physical quantities we have to write. Okay, how they are related. Mu is equal to real depth by apparent depth. This is what we have learnt in concept video. Our next question, an object placed in a medium when seen from a other medium appears to be vertically shifted. Name the factors on which magnitude of shift depends and state how does it depends on them. See, very simple question. This is what we have learnt in concept video. They are just asking what are the factors which affect shift and how they affect it. Very simple question. This is what we have learnt. Here also we are going to learn. Okay, first we'll write what are the factors which affect. Okay, so first one, refractive index. So I'm going to use the symbols. Don't use the symbols in the board exam. So you have to write this. This is the symbol for refractive index. You have to write it in full form. Refractive index, okay, is directly proportional to shift. So how you have to write it in the exam? Refractive index, full form this symbol also you should not use. This is for our reference. Okay, you should know how to use the symbols and all, because these and all will be used in some derivations, so you need to understand. That's why I'm using these symbols, but in the exam you should not use it. Refractive index is directly proportional to, you have to write it, is directly proportional to shift. That means if refractive index increases, so the meaning of directly proportional, that means if refractive index increases, refractive index of the medium increases, shift also increases. Shift also increases. See, refractive index will affect shift. Shift will never affect refractive index. The same concept. You can make dosa with batter. You cannot make batter with dosa. Okay. So understand this one. Refractive index is directly proportional to shift. That means if refractive index increases, shift also increases. Next, thickness. Thickness of denser medium, not any medium, thickness of denser medium. Again, it is directly proportional to shift. Directly proportional to shift. That means if T means thickness of the denser medium increases, okay, shift also increases. Shift also increases. That means they are directly proportional. Last one, color or wavelength. See, when it comes to light chapter, whenever we talk about wavelength, that means color of the light. Okay, so color or wavelength of light is inversely proportional to refractive index. Is inversely proportional to refractive index. That means if the wavelength, see, if wavelength, so it is not refractive index, it should be shift. Okay, it should be shift. So if wavelength, okay, increases, shift decreases. That is nothing but inversely proportional. The symbol is same. We are taking the reciprocal. In the exam, you should not use these symbols and all. You have to write color or wavelength of light is inversely proportional to shift or vertical shift. Anything is fine. Shift is nothing but vertical only. We can use normal shift or vertical shift. Both are fine. Okay. So 1 by S, that means if wavelength symbol is lambda. If wavelength increases, shift decreases. That's it. These are the factors, and this is how it will affect in the exam. If they are asking what are the factors which will affect shift, you have to mention refractive index of the medium, thickness of the denser medium, color or wavelength of light. Only if they are asking just to state. If they are asking how it is affecting, then only go for directly proportional or inversely proportional, or else you can write it as if this one refractive index increases, shift increases. All those things you have to write how it will affect. If they are just asking for state, don't write these reasons also, because your answer, okay, this statement may be correct. If the reason is wrong, then they will deduct mark. Why do you want to write extra and lose mark? If they are just asking for state the factors which affect this one shift, refractive index, thickness of the denser medium, color or wavelength. Done. How they are affecting? In this question they are asking how they are affecting it, right? That's why we are writing directly proportional or inversely proportional. That's it. Our next question, prove that refractive index is equal to real depth by apparent depth. Okay, see, in the ICSE board exam, formula derivations will not be there in ICSE board exam. So don't worry about this question. Derivation based problem they will never ask. Our next question, a tank of water is viewed normally from above. State how the depth of the tank appears to change. Draw a label diagram to explain your answer. Now we'll solve one by one. See, first question, state how the depth of a tank appears to change. So here we know whenever there is a denser medium, okay, assume we are talking about the tank and a person seeing it, correct? So this is denser, this is rarer medium, correct? So whether they are talking about tank, water tank or glass slab, the diagram and answer remains same. Keep this in mind, whether they are talking about glass slab or water tank, the answer and diagram remains same. Instead of this one tank, you can write it as glass slab. That's it. Now state how the depth of a tank appears to change. We know whenever light enters from denser medium to rarer medium, denser medium to rarer medium, whatever we are seeing, so we are seeing from rarer to denser, but light is coming from whenever you want to see something. What do you mean by how can we see object? Whatever the light falling on the object, if that light ray falls on our eyes, then only we can see the object. So if you are seeing some depth of the tank, that means whatever light enters, okay, enters into the medium, that should come out. If we see that ray, then only we can see an object, correct? So light can enter like this directly, or light can enter like this, see, like this. And we know light only travels in a straight path, rectilinear propagation, no straight. So because of the change in medium, there will be a refraction. There will be a refraction. See, from denser to rarer, speed increases. That's why it is going away from the normal. See, till here, if there was no medium, this light would have traveled in this way, correct? See, like this. Because of the refraction, it is going away from the normal. In these ways also I have to be very specific. If this ray is going towards the normal, then the diagram, whatever the mark is there for diagram, that will be completely wrong. So whenever light enters from denser to rarer, the speed increases, so away from the normal. Now see, whatever we see, this ray, see, if you extend this one, okay, this is the depth we are going to see. This is the depth we are going to see. See, we have understood what is real depth, apparent depth and shift in the concept video. Here also I am going to teach, but if you have that prior knowledge, then it is very easy to understand. See, if this ray goes here, because of the denser, it goes away from the normal, and whatever we see, if you extend this line, we see this is the depth of the tank. This is the depth of the tank. So what is the answer for this one? State how the depth of the tank appears to change. The depth of the tank appears to be lesser, okay, compared to the real depth. Okay, the depth of the tank appears to be lesser compared to the real depth. So this is the real depth and this is the apparent depth we are seeing. Whatever this depth we are seeing, okay, we'll see only this much of the tank. This is the apparent depth. The difference between real depth and apparent depth, this is called as shift. How much it has raised. Many students will get confused the difference between apparent depth and shift. How much distance we can see, that is apparent depth. How much it has raised, that is shift. So this is the concept. Answer for the first question is the depth of the tank appears to be lesser compared to the real depth. And if they ask reason why, if they are reason why or justify your answer, because of the refraction, you have to write because of the refraction the depth of the tank appears to be less compared to the real depth. If they ask reason, then you write refraction, because of refraction of light. Next, A is done. Then B completing the ray diagram. That's it. This is the completed ray diagram. Our next question: water in a pond appears to be only 3/4 of its actual depth. What property of light is responsible for this observation? Illustrate your answer. Okay, we have so many questions, we'll go one by one. So first one, see, whenever you see anything in a water or a pond or through a glass slab, okay, the object appears to be little raised. So this is because of refraction of light. You need to understand the concept, because just very simple concept, refraction of light. Because of the refraction of light, the object, whenever it is seen from the rarer medium to denser medium. Rarer medium means from air to water or air to glass or air to pond, anything, or air to lake, anything. So from air, rarer medium to denser medium, if an object is viewed, okay, the object will be appear to be raised. This is because of refraction of light. The answer for the first sub question is refraction of light. Then illustrate your answer with the help of diagram. Now we have to explain with the help of diagram. You have to write this diagram. This is what we have learnt in previous question also. I believe you can aramse write it. Now listen. So an object, this is how you are going to illustrate. These kind of questions will not be asked in the ICSE board exam, but for a safer side you need to understand, because why we have to learn all these things. Based on this concept they can ask any question. They may not ask you to illustrate it, but they may ask you any give reason type of question or any other question related to this concept. If you know how to explain whatever the question they ask, you can easily answer those questions. An object X, it is in the bottom of the pond. Bottom of the pond. Pond is considered here as denser medium. Next, the object is viewed from the rarer medium. An object which is kept at a bottom of the pond, it is viewed from the rarer medium, that is nothing but air. The ray xy from the object, the ray xy from the object, okay, enters rarer medium, that is air, as refracted ray yz, as refracted ray yz. This refracted ray yz produces a point x dash, as a reference point from the x, okay, as a reference point. The distance from x dash and a is considered as apparent depth. The distance from x dash to x is considered as shift. The complete distance, the complete depth, okay, of the pond is considered as real depth. And here one more thing they have mentioned clearly, it appears to be 3/4 of actual length. Actual length is nothing but real depth only. Actual depth is nothing but real depth. Keep this in mind. And they are telling 3/4, it appears appearing like 3/4. That means if you take this as 5 centimeter in the exam, see this diagram is not perfect. I am telling you how to write it. If this is 5 centimeter, okay, this has to be 15. They are telling 3/4 of actual depth. The apparent depth should be 3/4 of this one. If this is 5 centimeter, 5 3s are 15, 3/4, right? So if this is 5, this should be 15. If this is 2, this should be 6 centimeter. So in the exam you have to measure and write. So this is the explanation. Then how is the refractive index of water calculated from real depth and apparent depth? This is what we have learnt in the first question. This is the formula. Refractive index is equal to real depth by apparent depth. That's it. Our next question, draw a ray diagram to show the appearance of a stick partially immersed in water. Explain your answer. See, I am going to draw the diagram. The explanation what we have done in a previous question, the same explanation here, whatever the points we are using, the points you have to use. That's it. So I'll draw the diagram. Assume this is the thickness of the pond or real depth of the pond. This is the real depth or actual depth, but using the symbol is very much important. Don't use A, because we are using A for apparent depth. Assume you have immersed a stick like this, okay, a stick like this. Now see, from this point we know, okay, a ray can pass like this, correct? A ray can pass like this, but this line you don't have to mention as we have done in other diagrams, okay. From this point there are 2 points, right? The upper point and the lower point. From both the points 2 rays will go like this, okay. It has to be straight. Very important thing, it has to be straight. Whatever the diagram you are using, you are drawing in the physics, you have to use scale. If you are using a circular object, don't draw it as a rough diagram. If you draw it as a rough diagram, never going to get marks. In physics you have to use always the scale, okay, and don't use pen while writing the diagram, okay, use pencil itself. Next, because of the denser to rarer medium, okay, it goes away from the normal. Wherever these 2 points are coming, there we are going to see the object. correct. If you see from this angle, see it is going like this, but this is not the actual thing we are going to see, correct. If you extend these to refracted rays, okay, assume this is P, okay, this is P, here it has Q R, PQR, and this has ST. Okay, these are the two rays we are getting, okay, from the bottom of the stick, okay, from these 2 points, QR after refraction and ST after refraction, these two rays, if you extend these two rays in a straight way, wherever we are seeing these points are meeting, there we see it as bended. There we are going to see the stick is whenever it is immersed, it appears to be bent or appears to be raised a little bit, okay. Wherever if you extend these two lines, wherever these 2 points are meeting, there we are going to see the stick. So this is the diagram. Explanation is given here exactly like the previous question, so you can aramse write your explanation in your own words, but using the points, see this point is considered as P dash. Whatever the P goes, it appears to be present here, correct, bent or appears to be here, whatever the point we are using here, the same point P dash we have to use. Our next question, a fish is looking at 1 meter height plant at the edge of a pond. Will the plant appears shorter or taller than its actual height? Draw a ray diagram to support your answer. See, the complete height of the plant is 1 meter. In this question, the very important concept is where the ray is coming from, whether it is coming from the pond or it is coming from the plant. Very important thing. So how to draw in these kind of situations? Very simple. In previous questions, where was the object? Object was inside a pond and the rays were coming out of the pond. Where the object is there, from that point the rays goes, okay. We have to the arrow marks are very much important. I'll show you, listen, okay. Assume this is the fish. I'll show you how to draw the ray diagram. Assume this is the plant, this is the plant, okay. This is the height of the plant, this is the height of the plant. So see, from the top the rays go, okay, this is the ray, and because of the refraction, okay, it bends, correct. If there was no medium, this light would have gone in this way, but where you are going to write the arrow mark, in this way or this way, which is correct. See, always keep this in mind, the light ray goes from the object to the person or a fish is viewing it. So light ray always goes from the object. Which is the object here? What we are seeing, what is the fish seeing? The plant is considered as an object. Whatever we see, that is considered as an object. The light ray always has to go from the object. Keep this in mind. If the arrow mark is wrong, then everything will be wrong. So because of the refraction, it gets refracted from this one, rarer to denser, the speed reduces, so it goes towards the normal. So this is done. Now whatever the fish is seeing will not be seen this one. So if you extend this line, okay, if you extend this line properly in a straight way, whatever the height is there, this will be the height of the plant. So this will be the height of the plant. So what is the answer for the first question? Will the plant appear shorter or taller? Whenever an object is seen from rarer medium to denser medium, in the previous questions, rarer medium to denser medium, okay, the apparent depth will be smaller compared to real depth. See, rarer, in previous question and all, we were seeing from air to water or air to glass. That is nothing but rarer to denser, okay, rarer medium to denser. Apparent depth will be greater than real depth. Apparent depth will be greater than real depth, okay. But in this case, this is the object, okay, is in the rarer, and we are seeing from the denser. We are seeing from the denser to fish is in the water, right? So this is denser medium to rarer medium. In this case, denser medium to rarer medium, apparent depth will be greater than real depth. This is the real depth, 1 meter. Okay, only this much real depth, but apparent depth will be greater than real depth. This is real depth and this will be the complete will be apparent depth. So answer for this question will be the height of the plant will be taller than the actual height. This is the diagram. Our next question, a student puts his pencil into an empty trough and observes the pencil from the position as indicated in the figure. Now this is the concept. We are going to understand the question. What change will be observed in the appearance of the pencil when water is poured into trough? Okay, listen. Now it is empty. The trough is trough, or you can assume it as aquarium. This is completely empty. Now whatever we see, that is the actual length of the pencil. Now what they are telling, what change will observed when this complete aquarium or a trough is filled with water. When the water is filled, okay, you can fill it to whatever the level you want. When the water is filled, okay, then this pencil appears to be raised and looks shorter than the actual length. You're getting my point? Whenever the water is filled, then this pencil appears to be raised up and looks shorter compared to the real depth, real height or real length. Now this is the answer for the first question. Then second one, name the phenomenon which accounts for this stated observation. Okay, for whenever something is raised up or looks shorter, that is because of refraction of light. That is the answer for the second question. So second question answer is refraction of light. Third one, complete the diagram to show how a student eyes sees the pencil through water. Very simple. This we have done earlier. Okay, from this point, two rays will go because of the change in medium. They go away from the normal because it is from denser to rarer, speed increases, so they go away from the normal. Wherever this ray goes, that is what we are going to see, and we are not going to see the tip. If you extend these two lines like this, okay, if you take this as P and if you extend these two lines, this as P dash, you have to take this. If you take this as P, this will be P dash. This is where we are going to see the actual pencil. This point, at this point we are going to see the pencil. This is the ray diagram they are looking for. Now we have completed all the theory questions from the chapter refraction of light, that too simple application of refraction of light. So in this concept, understanding the words, understanding the terms, which is whether it is going from denser to rarer or rarer to denser, all those things are important. And the arrow mark always goes from the object. If you are seeing a plant, okay, object is plant, the ray should come from plant. The arrow marks are very much important. And the diagram, you know, if you practice, if you have seen this video, then you would have understood, but draw it one more time, then only you will understand. Because whenever you are trying for the first time in the exam, then definitely you will make mistake. Whatever the mistake you make, you do it in home or school, don't do it in board exam. So try it yourself, draw it, then only you will understand. So after this, we are going to solve all the numericals. That video will be available in the description box. Thank you.